Welcome to InnoBuzz Java Video Tutorial Part 15, Graphical User Interface. In this chapter, we are going to talk about the graphical user interfaces. We will know how we can develop Java program with GUI. There are the AWT and Swing classes that supports the GUI. We will learn what they are. We will see why we need to know both of them. We will understand how they work. We will study about the events. We will see what are they and how they work and why we need them. Let's see the overview of the chapter. First, we are going to talk about the Abstract Windows Toolkit, the AWT. The hierarchy of classes in AWT. We are going to see now the implementing of AWT classes. Then we are going to talk about the Swing API, the event handling, and at the end, the callback mechanism. Let's talk about the AWT now. The Java programming language provides a class library, which is called the Abstract Window Toolkit. This contains a number of common graphical widgets. This is a portable GUI library for standalone applications and applets. The Abstract Window Toolkit provides the connection between your application and the native GUI. The AWT provides a high level of abstraction for your Java program since it hides you from the underlying details of the GUI your program will be running on. The java.awt package contains all of the classes for creating user interfaces and for painting graphics and images. We have to stop for a moment now. When we display an AWT GUI, the JVM starts a new thread to watch for user interaction with the graphical user interface. This new thread sits and waits until a user presses a key, clicks or moves the mouse, or any other system-level event that affects the graphical user interface. When it receives such an event, it calls one of the event handlers that is set up for the GUI. Note that the event handler code is executed within the thread that watches the graphical user interface. This is an important point that will be revisited later when the events are reviewed. The important packages here in AWT. The java.awt.event. This provides interfaces and classes for dealing with different types of these events. Java.awt.transfer and DND. The following packages support drag and drop. This enables data transfer between applications. There are some packages to support advanced Java 2D graphics and imaging. The java.awt color and the font and the image. And for entering text, there are the java.awt.im and the java.awt.im.spi. Let us see the hierarchy of classes in AWT. The component and the container classes are the base of the AWT hierarchy. Both are in the java.awt package, and the container extends from component. An object that is an instance of component has the graphical representation that can be displayed on the screen, and the user can interact with it. The subclasses of component are the label for showing text, the button that creates a labeled button, the text component, which is extended by the text field and the text area. These are used for editing text. The checkbox that can be in two states, on and off, so it can be checked or unchecked. The container contains other AWT components. If you want to display a component, it has to be put in a container. The container also has some subclasses. The window object is a top-level window with no borders and no menu bar. A window must have a frame, dialog, or other window defined as its owner when it is constructed. A frame is a window with a title and a border which can contain menu bar and other components. A dialog is also a window with a title and a border that is typically used to take from input from the user. The panel, which can be used in other containers, but which is also the superclass of the applet that we are going to learn in the next chapter. Implementing AWT class. Let's see an abstract window toolkit example. What are the most basic ways to create an application with user interface? Make a new class, extending the frame class. In the constructor, we can set the name of the window, and if we set the visibility of this window true, with the set visible true, we can already start our program. But we cannot close our window, so we will do the followings. We will create an event for closing. Let's make a new instance of the java.awt.event window adapter class. It is an abstract adapter class for receiving window events. We should override the window closing method with the next, the system exit 0, and add the specified window listener to the created frame by calling the add window listener method. This way we created an event handler, and if we click on the X on the frame, it will close the frame. We will speak about the events and event handlers, event listeners later in this chapter. After we have done this, we can add components to our frame. We can set the size of the frame using the setSize method, and we can then add some panels, for example, which are also containers. So this way we can create a containing hierarchy on our frame, and we can set the position of the panel on the frame and also the other panels. And we can put other components on the panels. We can set the places also of any component. So we can put the text areas and checkbox labels, buttons, and so on and so on. We will see that in practice, and we will talk about them. What is a layout manager? A layout manager is responsible for the position and the size of the components in a container, sometimes also for the visibility. All containers have a default layout manager, but we can define another one, a different one as well. We can add the component to a container. We can set the position like a recommendation, because the layout manager determines the final position. In the Java language, there are 5 types of layout managers. The first is the border layout. It has 5 areas for positioning the items. One is the north, the south, east, west, and the center. The flow layout is the second. It is the default layout manager for all panel objects. It places the panel components in rows according to the width of the panel and the number and size of the components. The third is the card layout. This treats the components as cards, and only one card can be visible in a time. The fourth is the grid layout. This arranges the components into grid of rows and columns. We can set the number of rows and columns. The fifth is the grid bag layout. This is a special version of the grid layout. It's more advanced. This lets us set the size and the position of the components within the cells. We can make much more advanced things with it. We can put together cells, and we can arrange our objects more precisely in the grids. Swing. The swing is in the JavaX package. Swing implements a set of graphical user interface components that build on AWT technology and provides a pluggable look and feel. Swing is implemented entirely in the Java programming language, and it is based on the JDK 1.1 lightweight user interface framework. It contains all features of the AWT and more. A rich set of higher level components such as TreeView and ListBox, for example. The disadvantage of using Swing is that our application may become slower, and if we want to write applets, the web browsers will need the Java plugin. As I mentioned, the Swing is in the JavaX package. We will talk about in details the javax.swing, which contains the classes that we will use, and also the javax.swing.event, which will be used for the event handling. The Swing defines own classes which extend from the classes of the java.awt to support Swing component architecture. Let's see this architecture now, the hierarchy of Swing components. The G component extends the java.awt container class. As we can see, the Swing classes come from the AWT, and the names of all Swing components, Swing classes, start with G. So in the JavaX Swing, we can extend, for example, the frame of the AWT. It is a J frame. You have the J dialog, the G applet. And as I told, from the container, we extend the G component and the subclasses of it. The important subclasses are the JList, which displays a list of objects and allows the user to select one or more items. The JPanel, this displays an area for a short text string or an image or both. GOption pane is for pop-up dialog boxes. GText component, this is the superclass of the GText area and GText field, and the password field, which is the subclass of the actor. The G menu bar is an implementation of menu bar. The G abstract button and the subclasses of it, the G toggle button, G menu item, G checkbox, G radio button, and G menu. In a Swing program, we have to create an object just like we did in the AWT, but it will be an instance of the JFrame class. We don't have to create an event handler for closing. We just have to call the setDefault close operation method and give the exitOnClose constant field as an argument. And we have to use the setVisibility true, just like in the AWT. We will see it in practice. Event handling. There are some simple ways for getting input from the user, thus making our program interactive. There are lots of components, for example buttons, input text areas, checkboxes, menu bars, tables, and so on which we can perform event handling. A container can handle event if it implements the action listener interface from the java.awt.event package. It means this container has to have an action performed method that defines what happens when the action occurs. The action is defined in the argument of this method by the action event class, which also can be found in the java.awt.event package. If it is added to a component, it will be registered as an action listener, and when the action occurs, it calls the method. We can make more complex listeners, for example, registering one listener for more events, because we know the source of the event. Each event is represented by an object that gives information about the event and identifies the event source. Event sources are often components or models, but other kinds of objects can also be event sources. Callback mechanism in Java. The callback is a reference to a piece of executable program code which is passed as an argument to other codes. In other words, a callback is a mechanism by which the user's action on a software application's GUI is connected to the code implementing the application's response to this action. We can use this mechanism when we want to separate the GUI code from the code that implements the events. In Java language, we can make callback mechanism by defining a simple interface that declares the method that we wish to be invoked. That method will do the same what an action performed method does. The way of creating a program which works like this is the following. First, create a new class for checking if the action has occurred. This is the checker class. Then implement the interface in the container, the GUI container, and create a new instance of the checker class and pass the container to it. It is time now to create our own graphical user interface in practice. In this example, we are going to create a GUI which only uses the AWT and the AWT event packages. So we are not using the swing yet. This is a layout example. We are going to see other layouts here and add some action and item listeners. This time I use a different method because I've already written the whole code here. So I'm not going to write the code now real time. I've prepared all the code because this one is a really long code, and I can say in general about GUI programming, about the GUI program codes, that writing them is not the most complicated thing in general, but it takes a lot of time and a lot of coding, and of course a lot of trying and testing. So writing graphical user interface codes, creating graphical user interfaces is some way takes a lot of time. Sometimes to be precise, to put everything together, all the windows all the frames that we want to create, and we also have to test a lot to try out if it looks as we wanted, or we have to change the parameters a little bit, add it a little bit, move it to the right or to the left, the components. So we can spend a lot of time if we want to create a really good looking graphical user interface, and we will always find something to change in it. Now this time I have set up an example here. First I'm going to show how it works indeed, and then we are going to see the program code in details. So I start it. This is a layout example. We have the 5 major layouts here. I can select one of them. The border layout looks like this. We have some text here. This is a list. If I push the OK, I always get back to this start page. So you can see I can choose one from the left, and in the right panel we can see the corresponding layout. This is a flow layout with these buttons. They do not do anything, and if I push the OK, then we get back. The card layout, it takes a little time, which we already talked about. So we only can see one of them, just like the cards. We can switch between them with this chooser. The grid layout look like this. We have the buttons, and if I push one of them, we get the 2 columns way here, the 3 columns way here, 4 columns. So I can change them. The grid bag layout is the most complex thing here. I can add some comments. So I here, and we can use the whole GUI as we, and if I cancel it, I get back. If I push the OK, I get back. So it is something like this. We will see it in details. Now just spend a little time on going into the code. As I told, we only import the AWT and the event, and we extend frame and implement the action and item listeners. We have got some fields here, some buttons that we will use. So these are fields here, buttons and the panels that we are going to use, and the text field as well. These will show on the panels that we are switching. This is the constructor. Generally, it's the whole thing is a grid layout. So this, the general outlook. It has one row and two columns. We are creating a panel on it, and the first panel is this panel. We have 8 rows here and 1 column, and as you can see, we set the background to this color on the P1. The P2 is the other panel here. This is the P1, this is the P2, as you can see, and we add it to the frame, the main frame here. Okay. Now I am adding the buttons here and creating them. I'm instantiating the buttons with these texts here, and I am adding the action listeners to them. So from now on, if I push one of them, the action listener is going to be called. We are going to have a look at on the action listener right now, and we add it to the P1, which is this panel. We also add this text at the beginning, and as we have mentioned in the slides, the way to close this is we have to add a window listener with a new window adapter instance, and we have to implement the window closing method. This system exit 0. So this is just a general thing on the AWT. This is how this looks. Now, what is going to happen if I push one of the buttons? This is a possibility here to change something. I can push one of the buttons. Well, then we come into here this action performed. I start from the end somewhere. I start from the grid. If I push the grid like this, then the followings happen. We get here, the source was the grid. We remove everything from the second panel here. This is the second panel. We remove everything. We set the layout of the second panel, the grid layout, because this is the grid layout button. And we are adding these buttons, the 2 calls, 3 calls, 4 calls, and the OK button. We are adding action listener to them, which is going to be in the same method as we are going to catch these actions here, the same action listener, a little bit upper. And we are adding a new label, this label, and that's all we do. We are adding these, and at the end we validate it. Okay, just let me show you some informations about these. The removal, as you can see, it removes all the components from this container. So this does that. The second panel, we are removing everything. It also notifies the layout manager to remove the components from the container's layout. Okay, so this is what we will call every time when we push a button. And the validate is also interesting. This is going to be also the ending every time. This validates the container and all of its subcomponents. So this means that it will lay out the subcomponents. So this will help us to show and to finish the thing. So we add everything and we put it together, put the whole container together, the whole panel, and we validate. So this will apply the changes. So this is was a simple thing. We created a grid layout with 5 rows here, as you can see, 5 rows, 1, 2, 3, 4, 5, and 1 column. And we just added things, and we can see that the first is a label and the buttons here. That's it. Now, if I push one of them, for example the 3, then it changes. We have to find the action listener, the 3. It is a little bit upper, the 4, the 3, and the 2. So if we push them, this is going to happen. If we get the 3, for example, we remove everything from this panel. We set a new grid layout, which is 0 rows and 3 columns. And we are going to add these buttons, and that's it. In fact, this is not enough place here for it, so yes, so it uses another row, and we add the action listener to the OK button here. We use this OK button on every panel, and we validate. This is what we do, and the same with the 4. The difference is that we use the grid layout with different numbers, and that's why it's gonna have 4 columns here, for example, and so on and so on. So this is 2 columns. That's it. Okay, let's see what we have got here. We started with the grid. Now we follow it with the card. The second is the card that I'm going to show. If I push the card, now we get here. I'm trying to hide it a little bit so we can see the code. If it was a card, of course we remove everything, and we are going to create the panel with a border layout, the P2, so the panel 2, and we are going to create 2 strings here, which are going to be part of the choice. The choice is this. We can choose between the 2 cards here. So we are going to create a choice with these 2 possibilities, with these 2 strings, as you can see. And we are adding to this C2 panel. Well, we put the label card layout, and we put it to the center, and we give the card label here. This is the card label, the card layout, and that's it. And this interesting thing is the cards is a new panel here, and we give the card layout. This is the main point here. So on this panel, this is the new panel, we are going to use the card layout. And the 2 new panels which come here, the P3 and the P4, are going to be parts of this card layout. So we have the OK button, the quit button, the reset button here, but you can see, and we add all of them to the P3. This is one of the panels. The other is going to have a text field, enter name, and we add it to P4. Now what we do is add these panels to P3 and P4, and we also specify that the two strings, that one of them belongs to the bottom panel and one of them to the text panel. So whenever we will use this choice, then we can specify with this string which panel belongs to which choice here. And that's it. So we are going to add to our P2, which was the main panel here in the right. We are going to add the cards, which was the card layout. And we are going to add some action listeners to the OK, and also an item listener to the choice. This is the choice. Whenever I change it, something happens. So this is for the item listener. We are going to check it now. A little bit further. So this is the item listener here. So whenever I change something here, this is going to be called with an item event, as you can see here. The item event comes into this item state changed, and we are going to get the card layout. So the cards dot get layout, the layout of the cards, which was this panel. This is a card layout, and we are going to show on this card layout the cards with a specified string. The event is going to tell us from this choice which string we have chosen. And if we choose this string, then it will show the corresponding panel part. So that's why we have set two panels to the cards, so we can choose between them. And the string is going to help us to identify, because the event, we'll know the event object here, the item event object, we'll know the string, we'll know from the item that which string was what we have chosen. So if we have the show panel with buttons chosen here, then we can see that this is the button panel string, and we have added it to the cards here. And this is the P3. The P3 has got these OK and quit and reset buttons. That is the trick here. We also add the action listeners to the OK button and also to the text field. So if I enter something here in the text field and I press enter, then we get back to here, just like as if I push the OK button. So this we can check here, because if you use this T field, then we remove all and we get back. So this is all the same thing as if I've pushed the OK button here. No difference. The cancel does removing and validating and the grid back. So we don't get back to the start with the cancel. But we don't have to cancel it everything everywhere. We have a cancel here. So this is going to clear this grid bag, but we are not there yet. I want to follow the logic that I started. So we have seen the card layout and how it works. Now it's the flow that we are going to show. If I use the flow layout, we have these here. So I push the flow, we removed everything from the right panel, we set a flow layout. This is a new label. So this we just have some lines here. And actually we get the buttons and we are adding them one after the other. And the flow layout does that depending on how long these strings are. It will choose the length of the button, and also when we add, if the corresponding button is too long to fit in the first line or in the second, then it will put it in the next line. So we can see this. Here we just simply add them and add the OK at the last, and also add the scroll bar here. It's a horizontal scroll bar, and we add an action listener only to the OK, so the others don't work. They don't do anything, and that's it. We validate. That is the flow. If I push OK, the same thing happens. This OK button is the same on every layout. Now the next one is the border. The border layout here is also a simple layout. We remove everything. We set the border layout. It's okay. We have a label which is in the center here. This is the border layout. And we create a list here with 6 items, and we push these, we add these strings in this list, and we add the list. Yes, we have the OK button, and we add to the north. So we can, as I've told, we can use the north, the south, the east, the west, and the center. So now we use this, specify it with a string. So the north is this, the label. The center is the items. So this is the list. And at the south, this is the OK. So we can create panels which are not very complicated because it only has 5 different parts here. And we add the item listener to the OK. So this is not very complicated here. The next one that we are going to check, I think we have already seen these. This is the T field and the fourth tree that belonged to the grid bag, to the grid layout, and we are going to check the grid bag at last, because this is the most complex thing here. If it was a grid bag, what happens then? If I push the grid bag here, this comes in. Well, as you can see, we also use the removal here, validate, but inside it, this is a method called the grid bag, because it's more complex. So there is a method for it, a standalone thing. Well, the grid bag layout is a little bit like an advanced grid layout or something. We can set up the grids, but we can set up some constraints that inside the grids, what is going to happen and how we use these grids. So this gives us much more possibilities to create things. Now, this is the grid bag constraints object that we are creating here. This will help us to put the things here. this is a new grid bag layout, and we set the layout to this. So the P2 has the grid bag layout now. Now what is going to happen here is that we are going to set some things. So we use the same grid bag constraints object to set one by one these components here. So we are adding them. We add the top, the name, the address, the comments, and so on and so on. And we are always using the grid bag constraints here. And what we are doing is we always change something. With this C, as you can see, we use it many times here. So we always change something with the C. For example, here we change the field. Now what is this field? You can see this is field is used when the component display area is larger than the component's requested size. So we are using the both here, which says make the component fill its display area entirely. So this will fill the display area, what is possible, and this is will go with the top label here. So the label is going to be as big as it is possible for this area here. Okay, it says the width of it is the grid bag constraints remainder. Well, in the grid bag constraints, there are many constants like this. The remainder specifies that this component is the last in this column or row. So this we use it because this is the only component here in this grid. So this is the upper grid here. Okay. So we create a label, and the alignment is going to be center for it. The text is in the center, and the grid bag we set the constraints. So we on the top, so this label with the C that we have set up here, and then we add. This is the method that we have to do with all. So now this is here. Okay, then we will give the name text field. There is a text field which is name. This is 25 characters wide, and we set the constraints just like before, and we add it. The only thing that we have changed on the constraints that it is relative, and this means that this is not the last one. There is also going to be one more in the same row, and this is going to be the address here. So for the address, we set its remainder as we did it here. So this tells that this is going to be the last one in this row, and we create a text field just like the previously, and we set the constraints for it, and we add it. So this way we have done the second row here with the name and the address. Okay, now comes the text area here. I come a little bit lower. The text area is a new text area with 4 lines here and 25 columns, and we set it editable, so I can write some things here, and there is default text here, and we do the same thing. We don't change anything. We set the constraints of the grid bag for this. So this is going to be a new line in the grid bag, because we have already told that the remainder, so was the previous text field. So there cannot be more in this second line. So this is the third line now. and we are putting it there, and that's it. And this is also a remainder because it's the only one in this line. Okay, so we didn't change anything on the gridback constraints. So the same constraints are going to be true for this one when we set the constraints. The constraints that we have applied on C are true here as well. This is the way it is done. We can, of course, create a different gridbag constraint object for each and every element if we want. Okay, now we add these comments, then we change things here on the gridback constraints, the insets. Well, this shows that 15 here is that there is 15 this distance 15 pixels distance between the top here of the button and the bottom of the previous line, and that's it. And we are going to create a relative because we will also have another one in this line. Cancel. This is the OK button, and we add it to this set the constraints, and we add it. The same thing we do with the cancel, and that's it. We add also the cancel here, and that's it. That is how to set up gridbag layout. Of course, we can spend a lot of time with trying out everything with the gridbag layout. There are lots of possibilities to use them. We can set many things. So this is the most complex thing. So we can set up very complicated panels with this. But it takes a lot of time to get familiar with this kind of layout, and also the constraints and the ways to give the components to it. We are adding an action listener to the OK and the cancel. They are the same things as we have previously done. If I push OK, we get back. So this is mostly what we have seen. The main method is only creating an instance of our class. We set a title for it, layout example application, and we pack it and set visible true. So this is only a few lines. I think we have seen everything here. So this was all the layouts that we have studied in the AWT package. We are going to create another example here, another program code, which is going to use the Java x.swing class and this package, and we are going to create some GUI again. This time I want to show different things. We are going to create the whole program real time, and we are going to create a simple GUI for a program which will convert Celsius into Fahrenheit. Now, to be able to start this, I'm creating a new Java class here, but this time I could start with the Java class as well, but I also want to show you something else. There is a possibility in the NetBeans also to create things from a designer view. And if I choose here the G-frame form, then I have the possibility to use the built-in designer in the NetBeans IDE. So I choose the JFrame, and I call my class Celsius converter. Okay. Okay. You can see that there are two possible ways to look at the change the code. We can look at the code here. This is made with more with a template, and we have got some more comments here that we previously got. If I can clear some of them if I don't need. Okay. It helps me. It tells what these are. Okay. We will talk about these as well. So this is the source view. We can see the source code. And of course, as previously, we always create Java files, which are the source files, and the JVM can work with the class files that are going to be after the compilation of the Java files. So we will use the same thing here, but there's a designer possibility which we can use and which will help us to create some codes. This helps us to make it visible a little bit, because when we are creating GUIs, then sometimes it is better to use it when we can see what we are doing. For this one, we have got a JFrame here, the javax.swing.jframe. This is it. I add a panel to it. First, I make it a little bit smaller, just like this, and I add a panel to it. You can see the designer helps me a little bit with this anchoring and also setting the size of the object sometimes. So if I moving the left then and the right, and it helps me to fill the whole frame. Now the panel is on the whole frame. We can see the containers and controls here. This is the swing containers: panel, tablet pane, split pane, scroll pane, toolbar, internet frame, layered pane, desktop pane. These are the different kinds of panels that we can use. For example, an internal frame is a frame which is inside another one, so it's something like a pop-up or something. The scroll pane has the scroll bars. The split pane is different panes which are splitted. The most general is a panel. The controls here, the label that we know with some text, the button, of course. This is a G button, and every of them is the javax swing.g. This is a toggle button which has two states. Checkbox, it can also be checked or unchecked. Radio button, we can create a button group with this, and the radio buttons also can be checked or unchecked, but only one of them if we put it into a button group. The combo box is going to help us to choose from different possibilities. There's a list that we have seen, previous list of things. Text field that can be used to write out text and also to get inputs, text input. Text area is a bigger thing, a whole area. Scroll bar, we know it, a slider. We can grab the slider and select things, select values. Progress bar, here we know it. It shows the progress, just like in the Windows applications. Password field and so on and so on. We don't really have time for everything. Three kind of objects arranged, and the table. There are some menus here, swing menus, and some swing windows as well. So some special frame, file chooser, color chooser. These are built-in things that we can use, option pane. And also we can see the AWT things here that we have already met. Some of them are the same, but these are from the EWT. And as we can see, there is less in this package. And it is better to use a swing if we create a swing. Okay, for this one, I will use some labels and the text field. I use a text field here. We are going to get the information from this one, what we want, and I'm going to add the button here, and I'm going to use two labels. Okay, and this is a kind of free when we, for example, this is the panel that I've clicked on. You can see that it is marked. This is the panel that we use. We can see the properties of it. There is a property palette for every component that we can use here, and there are many options that we can change. Every object, every component has a different property palette. So, for example, for this, there is the background color. If I want to change it, I can choose a red one, then it's gonna be red. Okay. Well, that was better. Previous one. Well, it's not the same. We can change the color with the typing the number if we want. Okay, the border we can set. The foreground is the text on it. Lots of things we can really change here. We can set the font, what we are writing, the size, minimum and maximum size, and also the preferred size, which is this, which is the size that we can see now. Yes. So it is good to look around. We don't really have time to check everything. We will see such properties. Also, for example, now we are going to change the labels. So let's, I can edit the text, for example, here, but I can also set anchors here. It is automatically set left and the top anchor here, the resizing and the default size, and lots of things I can do here. But in the properties, I think most of them can be done. So I just say that this is the Celsius. This is going to be our Celsius, and in fact I want a little bit bigger letter or something like that, maybe 14. It's okay, Times New Roman. Okay, and it became bigger. It's okay. That's it. Well, I don't want to do anything with it. What do we have here? Well, also lots of things that we can. The size is this. This is going to be good for us. Well, this is only a label, so we don't. You can set a tooltip text here, for example. This is the tooltip. Okay, so we are going to get a tooltip when there's a possibility also to view our preview design, so the view our what we have done, and it looks like this. If I come here, there is nothing happening because we are the events are not happening. This is just a preview. Sometimes it is good to check how it looks, what we have done, but the things won't work here. Okay, now change the other label just like this. Let's say this is the Fahrenheit. Fahrenheit. I hope I type it right. Okay, I set it to the same size, it's okay. Well, in fact, I want to set it bigger, the preferred size, because I will write the text in here. Okay, this is just some setting. Okay, actually, what we need here in this text field, I don't need the text here, any text, and I also changed the font here. Oh, I could have used the Times New Roman. Sorry, I think I forgot to set it here as well. Okay, okay, that's why we've got different. Okay, the button is also going to be the text is convert. We are going to convert with this one, and okay, now just we have to use the same thing. Okay, that's it. Now what we are going to do with this one, you can see this is a different property palette here because this is a button. So for example, for a button we can change a lot of things. We can set an icon for it, for example, and also set a lot of things for the icon. So this can be an icon for selected if and the rollover. When we go over a button, then it's a rollover situation that this is going to show the rollover icon. Then if we push it, then it's the selected icon. So it can change. Well, in fact, there is a built-in way for that. So just like this button, when I go over it, it changes the color, and if I push, it changes it. So this is where there is a default template for the Windows buttons with this grayscale kind that is already built in. But if we can change it with using all the icons, we can set them, for example. But what we want here is create an event for it. As you can see, for this simple button, there can be these many events that we can assign to. Well, mouse exited, mouse moved, mouse pressed, mouse released. There are lots of things. Item state changed. But what we really need here is the action performed. So when we push the button. So we say, okay, button, this is a name for it, okay. And when I push it, I already get here to the code, and you can see there is generated and there is a method generated for it. Private void G button 1 action performed, and then there's an action event here. And I can add my code here. We will add the code here. Well, this is already together a little bit. So this looks like this. Well, this is okay for us for trying. If I come here to the source code, I can change the things. Well, I'm adding my program code here. So the important thing here is that you can see some gray lines in the NetBeans and also the normal whites, and they are different because the grays are created by the designer. So they are generated codes, and sometimes they are put together so we cannot see them. But if I push it like this, then it shows that this is all a generated code. But in fact, this code has nothing very special. I could have written the same thing here. So it only creates instances just like we did before, and sets the default close operation on the window in the Java swing way, sets the background, and sets a few things that we have set. The time zero man we have set with 14, and so on and so on. Sets the text that we have set to this G button. So you can see that what we have done here happens and generated the code. And of course, there is also a layout added to the panel. This is a group layout here. This is a layout of the swing. This is more free to use, this kind of layout. Yes, the panel is added and all the others are added. So this is actually not a complicated thing here, but it is easier because it saves us time. So the time that we would have spent on writing this code is saved by just putting things here, and of course I can change things here, but we should be careful because it says that do not modify this code, because the content of this method is always regenerated by the form editor. So this is, if I change something here, it's okay, and I save it, I can run the code, but whenever I come here, it will regenerate it again. So I cannot really change it. Well, we can use tricks that we just simply copy all the text out and put it to another file, so we can use it as at the end when we don't want to use the designer anymore. So if you say that we had enough of the designer, we have designed everything what we wanted, then we can use the source code as a text and do whatever we want. We can copy it and create another Java, and then it won't be regenerated anymore. For example, this is a trick that we can do, but then we cannot use the designer anymore. So I want to add my code here. This is a blue line between two grays, so I can use it here, and our code is going to be very, very simple. There's an integer. This is going to be Fahrenheit, and we will use here the text field. The text field, this is the text field, our text field, G text field 1. And I want, yes, so you can see that there are many possibilities, many that we can use. Well, I want to get the text out of it. Get text. It gives us a string what is in there in this text component. Okay, this is a string. Now what we want to do with this is we want to make actually we want to make a number out of it. I cannot know what kind of number that is written. I just suppose it was for example a double. I use the double class here. It has got a parse double method, which is applicable on strings. And this way I already got a double here, and I'm going to create an integer out of it. So no matter this will work on a double, but of course we will lose the parts after the point, the decimal point. Okay, and in fact, okay, what I want to do is create the Fahrenheit. So this is a mathematical definition for it is I have this double, and then I make a multiplication with 1.8, and at the end I add 32. Okay, let's see. So this is the double that we get here. I make the multiplication at 32, and at the end I create an integer out of it. I hope it's gonna work. And what I have to do here is at the G text field and use the set text. Set text. So this, and or I also use Fahrenheit. Fahrenheit. Okay, but that's it. This is going to be, I hope it's going to work. I save it. Okay, let's run the file. Okay, I write something here. At the moment here is like 23 Celsius. If I convert it, well, I got the Fahrenheit here. It's funny, it's okay, it's working, but in fact I wanted to write it here on this one. So I wanted to use a G level 2. Okay. I save it and I run it. Okay. I use a different one. The last week we had something like 35 Celsius here, and it was 95 Fahrenheit. Well, that's it. This is a simple example here, and this is the way we can create a simple swing window, the swing GUI. And what the important things were that we can use well, for example, it created for me a void main also, and some additional things as well. It also created, for example, for me, look and feel information. This is a default. The Java Swing user interface manager, and this is a look and feel type of. So we are going to create an inbox kind of. This is a default here, and we are going to set the look and feel to this class, for example, and it generated also the try catch block here for us. This is also something which is generated by the designer here. As I've told, we don't need to use this designer if we don't want. We can do things without it, of course, just like we did with the AWT, but it can help us. For example, of course, there are also designers in not only in the NetBeans but in other compiler and editor programs that we can use for Java. So yes, the run is also created for us. So this is a new runnable created here for the avt.evenQ, and this is this runs our application set visible true. It creates a new instance of the whole class and runs it. This is how the whole window and the whole frame is going to be visible. And there is an init component which is always there, and we are going to use this that is generated here. That's it. These are the private elements of the fields of our class. So this was an example of creating a Java swing frame and make some swing things here, and also to add some codes as well. For example, with this action perform, we could spend a lot of time on creating more complex GUIs, but this is good for beginning.